Now we need to know the how to configure the IP addresses in the TCP/IP settings of your computer. So IP address version 4 can be set in a static way or dynamic way. So if we look at the Windows configuration and we get to the TCP/IP settings here, we can simply and then configure, and when we configure, we see that the IP address looks like this, and then this is the subnet mask, and this is the gateway. So the gateway is part of the network, and it takes one of the host addresses on this network. So this means that the IP address settings are set statically, which means that they are manually configured. The other way of setting up the IP address is to obtain an IP address automatically. And in that case, we connect to what we call Dynamic Host Configuration Protocol Server, or DHCP server. We will learn about DHCP as part of the application layer in Chapter 10. As we all know, there are three ways of communication between the hosts. So we can use unicast, broadcast, or multicast. So this destination here is 172.16.4.253, which is obviously a unicast address. So a unicast address supports the transmission from one source to one destination, as we can see here. So the unicast traffic goes from one source to one destination, as we have learned before. And the way to indicate that is using a host address in the destination address, as we can see here. So as we have seen before, if the destination is a broadcast address, which is in that case all ones, which means that broadcast, and in that case, if the source sends a broadcast message to all the ports except the one that it came from. And one thing to learn here, or to notice, is that broadcast packets are never forwarded by the router. So the router will actually suspend or stops the broadcast packets. Multicast transmission uses a special type of address, which usually starts from 224. So a 224 address represents a special class of address, which is multicast address. And in that case, those two hosts are part of the same multicast group, which is 224.10.10.5. So in that case, if a source wants to send to this multicast group, it actually forwards the packet, and in that case, they will go to these two hosts that belong to this multicast group. So these, in that case, they are called multicast clients. So this exercise here tries to get us familiar with the different types of addresses. So we'll take 1 minute to observe the network. So this network responds to 5 different hosts. We can notice that each host has a unicast address, which is 192.168.100.1, 2, 3, 4, and 5. So this is the host. This is the host part. So we also notice is that this is a multicast group that has this host and this host, because they have the same multicast address. And this host and this host belong to the same multicast, which is 237.192.126.17. So in that case, once we click start, we see the destination address here, and then we need to know whether it goes to one host, or it goes to all hosts, or it goes to one multicast group. So let's start So 192.100.5, so that's obviously this one. That's a unicast address. And let's see if that's correct. Correct. All right, so next. So that's also a unicast address, obviously, and that goes to this one. Let's see if that's correct. Correct. All right. So, and in that case, this is a multicast group, and it's obviously this one. So that goes to this host and this host. Yes. So this is also a multicast group. Let's try to select one so that that's the wrong answer, obviously, and in that case, it's you have not successfully identified the transmission type. So so you need to be careful. And this one is again the same thing. So if we try to select both of them, so that's a correct multicast group transmission. So that exercise here shows how, or gets us familiar with how to calculate the network part and the host part, and how from that we can calculate the broadcast address and the first and last host addresses. So that address is 150.81.165.113 / 26. So we can recognize that only the last byte is the one that we need to worry about, and in that case 113, so we can convert 113. So 113 is actually it's not more than, or it's not greater than 128, so that's 0. It's greater than 64, so that's 1. If you subtract 113 from 64, so that's 9 and 4. So 49 is greater than 32, so we put 1 here, and then we subtract 49 minus 32, that's 17. And obviously 17 is greater than 16, so we put 1 here, and that's 16, so that 1. So 16 is actually 0, and the rest is 0, 0, 0, and then 1. So that's how we convert 113. So we need to keep that number, and then if we add this with 26, so we need to be careful that the first, in that case, the first 2 bits here are part of the network part, and those 6 bits are part of the host. So in that case, so we need to enter the last octet in binaries, 01000000. So that's 01 here, and then the rest will be zeros. And that's obviously 64. So and in that case, the full address in decimal would be 150.81.165.64. Okay, and the broadcast address will be 01111111. Okay, which is take the host part and put all ones, and the network part is the same. And in that case, this number corresponds to 127. So the full broadcast address would be 150.81.165.127. All right, and then the first host address will be, of course, 01, and then all zeros, except for this bit here, which is, in that case, it's actually 64 plus 1, so that's 65. And in that case, the full address would be 150.81.165.65. All right, and the last host address will be 01, and then we put all ones except for the last bit. So the host portion will be all ones except for the last bit, And in that case, all ones, remember that the last one is 127, so this will be 126. So I don't have to convert again all this bit representation into, because I know that the last one will be the broadcast address minus 1. So I don't have to really convert it again. And this is 150.81.165.126. So let's see if that's actually correct. Are all correct, so that's good. All right.